I'd like to thank Monine and Gert for their hospitality. It's been a real honour to be asked to come and talk to you. What they've actually asked me to talk about is putting building information modelling at the heart of a small practice. And this is something that we're particularly passionate about, and to try and share some of our experiences of doing that over the last 10 years or so. In order to talk about that, it's important for us to give you a little bit of context of the environment that we work in London. So we're in a very crowded marketplace. There are 32 architecture practices with the same postcode as us, and within a few hundred yards of where we work, we think there's about 1,000 qualified individual architects. So it's an incredibly intense place. There's lots of work, but there's a lot of people fighting for that work. The other thing that we're experiencing is that we felt a real downward pressure on fee income since 2008, since the global recession. And I would say our fees are about 20% lower now than they were in 2008. And added into that, our rents doubled. So we're experiencing all of the economic pressures that I suspect every other architect is experiencing at the moment. And from the conversations that we've had over the last couple of days, I can see that that's something that's common to everyone. The other important piece of context that I think that we're working in, and I suspect that might be happening here as well, is risk-adverse procurement processes are beginning to polarize architecture in the UK. So what we're getting is a separation of small practices and large practices, with small practices being marginalized to just the design process, and larger practices sweeping up much of the delivery part of the process. And this is about a perceived risk that perhaps doesn't really exist, but it's to do with size. The other thing that we're seeing is the salami slicing up of projects into the different work stages. So instead of being commissioned to do a project from inception through to completion, we're often finding ourselves having to re-tender for the project at different stages. This is to drive cost out, but it's again associated with that perception that a smaller practice is perhaps risky when it comes to the delivery part of the process. So what we realized was that for a small practice, and a particular small practice trying to grow, it's important to develop techniques to distinguish ourselves in that really intense marketplace, but also try and develop techniques that can counter that assumption that small equals risk, because we don't believe it does. So if I can explain who we are a little bit, we're a team of 20 people based in Fitzrovia, which is a small area right in the centre of London. We're just north of Oxford Street. Much of our work is in central London, nearly all of it, most of it in the city of Westminster. So in a way, we're a local practice. We just happen to be in the middle of a big metropolis. We've actually grown since 2008 from a team of 4 to a team of 20. And we think that a lot of that is associated to the techniques that we've developed around building information modelling. So we came to this through through three-dimensional problem solving, through three-dimensional modelling. It's led us on to building information modelling and managing data, managing information and better flows of information. But for us, the initiation was trying to find a better way of producing, a more linear way of producing our information for projects. So my personal background was in the design and delivery of buildings with very complex geometry. So we were always looking for better techniques for communicating that geometry. And then what we try to do is take those techniques and apply them to everyday problems, the sort of problems that we experience in our smaller practice. So what do we do? Perhaps 2/3 of our work is housing. There's a lot of housing being built in the UK at the moment. Nearly all of it is on complicated infill sites, so tight geometry, difficult sites, lots and lots of demand on the projects. There's very high land values, so there's usually very little money left to spend on the building. So there's a lot of pressure there as well. The other third of our work is in the education sector. We do a lot of schools. We work directly with the EFA, the Education Funding Agency in the UK, as client advisors as well as architects delivering schools. And we've perhaps got 13 schools at various stages of completion at the moment. And our biggest projects to date are sort of mixed use projects. So the 35 million pounds, I can't do the maths in my head, but that, for us that's quite a big step. But I think what we've realized is what we're beginning to be acknowledged for is developing technology-led solutions to solve particular problems, quite often around program or difficult sites. So it's the idea of using technology to try and unlock projects that perhaps are stalling because of the complexity of the environment that we're trying to work in. So why building information modelling? So you may be aware that in the UK we have a mandate from UK government that all publicly funded projects have to have a building information model developed to what they're defining as level 2 for all projects from about this time last year. So there's definitely a push towards building information modelling. That mandate it's beginning to take effect, but there's still plenty of ways of avoiding it. So there's still quite a lot of pressure to find ways around not to deliver to level 2. And I would say that there isn't a single tender that comes into the office at the moment that doesn't have some amount of building information modelling within the tender. Quite often the client doesn't know what it is that they're asking for, but it's there. So there's clearly been there's clearly traction developing within the industry to sort of move in this direction, and clients are beginning to see the value of it, whether they fall under the mandate or not. But for us, we think that's to miss the point. Why we came to it in the first instance, and what we're having been through a 10-year cycle of development of our processes. We believe really it's all to do with the efficiency of our processes within the practice. So we all know that as architects we can add an enormous amount of value very quickly with our ideas and our design approach. But really the time it takes us to document and to record and to communicate that information erodes that value and ultimately erodes our fees. And if we're working in an environment where there's constant pressure, downward pressure on fees, that becomes really quite important. And we think that building information modelling has allowed us to become efficient enough to be able to become profitable and have a sustainable future for the team in the office. So why did we come to this? So initially going back, what we were attracted by was three things, but they sort of fall into two categories. One really is a better way of working, a more collaborative, less adversarial way of working. And what we've found with building information modelling is that we've started to be able to work with, we've started to be able to choose our friends more carefully. So basically people who are working this way have started to huddle together because they can share in the benefits. So we're finding that we're working in much more collaborative, less adversarial teams. But for us, as a small practice trying to grow, what was really important was the embedded quality control and coordination of the process and the consistency of output that we were able to generate, which would allow us to maintain the confidence of our clients as we go forwards. Because as a smaller practice trying to grow, they're sort of almost waiting for you to fail. So if your output can be powerful, coordinated, consistent, they start to gain confidence in your capability. And we think it's over 80% of our work is repeat business with repeat clients, and we think this is a consequence of that consistency and reliable output. And at this point, really, during the development, we started to talk to lots of larger organisations that were trying to adopt these processes, and we realised that it wasn't actually the training or the cost of the software or anything that was the barrier. It was change management and embedding the processes within the practice that was difficult. And as a small practice, we had it easy. It was really easy for us to almost make a gut reaction, a gut feel that this was the way to go, so that we could almost overnight take on these processes and start developing them. Larger organisations were having to demonstrate return on investment, report on progress, that sort of thing, and that's creating problems for them or stalling the process. So in a way, it was the realisation that there was a tactic here for us to be able to move quickly, use the agility of small practice to give us a commercial advantage in a difficult marketplace. So for us, the timeline of adoption really goes back over 10 years with an initial purchase of software, which we didn't even think of as BIM. So what we were doing at that point really was looking for just a better workflow. What we were finding, we were already 3D modelling all of our projects in software in Rhino, but what we were doing to communicate that information was we were then reverse engineering it into two-dimensional drawings. So we were flattening it and putting it into AutoCAD to communicate with contractors. And it was the realization that there were products on the market that were beginning to have a more linear workflow where we could develop that model and then actually the output could be just a consequence of developing that model. So that was really the idea in the first place. And that looking back, we really think of that as the lonely BIM environment. Because at that point, really, it was just we were working on our own. We were using the software. We were getting good productivity from it, but it was just for us. There was no one else involved in it at all. So through the communication process and sort of beginning to huddle together with other consultants and a little bit with contractors, we moved into what we've really thought of as a collaborative BIM environment, but it was an informal collaborative BIM environment. So what was happening is that we were starting to share models, we were starting to federate models and get real value out of that coordination process, and we were beginning to share them with contractors, and they were using them as well, or playing with them a little bit as well. But we were still in a very unstructured way of working. And at this point, the UK BIM level 2 definition wasn't there. So there's quite a detailed definition of what that is. It was still in development at this point. Where we are now is in a contractual BIM environment, where I'd say that probably 2/3 of the work within our office has a contractual BIM deliverable. So we're actually obliged to produce a model and to share it in a particular way. So it's a very clear protocol that's appended to our appointment. So there's a real traction there. In this contractual BIM environment, there's obviously an awful lot more bureaucracy, and there are more people involved in that process. But I'll come back to that at the end. But those three phases, I think, are quite important in terms of the development. So for us, this is actually the key slide, because this is where the penny started to drop for us. We were working on a series of a dozen school projects in London boroughs with the same contractor client, and each project is in a completely unique urban location on a tight urban site. Most of them are in conservation areas, and some of them were attached to listed historic buildings. So every one of them has to be a totally unique response to its site. So they're all completely unique buildings, But what we realized going from project to project was they were effectively being made out of the same things. They've got the same windows, they've got the same doors, it's the same furniture going in there, the same floor finishes, they've all got concrete frames. So the realization was that we were beginning to sort of develop a kit of parts, a virtual kit of parts for that building type and that contractor type. So what we started to do was be more formal and manage that content more carefully, so that from project to project we could refine that kit of parts, attach more information to it. Some elements would drop off and new elements would come in, but the key thing is that we were able to take the learning from one project to the next project and effectively evolve a library of components that were specific to that client and specific to that building type. And that really led to the last project in that sequence, which fell into the contractual BIM environment, where everyone started to realise the value of that. And we were on the last project, we were contractually obliged to use those methods. And I have a little case study at the end about this project, so I'll come on to that in a minute. But of course, the same techniques can be applied to other clients and other building types, and these are all projects for housing projects for a developer, private developer client who has very little interest in the asset management tool at the end, but can see the real value of de-risking the project by using the 3D model and the kit of parts as we go through. So you can start to see how, if you understand your client by going through a process of analysing what their pain points are and what they need from the model, you can start to actually sort of manage your content and your starting point for each project. So instead of starting with a blank sheet of paper, really you're starting with an idea of where it's going to go. And size isn't a limitation on this. From the smallest project to the biggest project in the office, we use these techniques on all projects and have done since 2008, 2009. The other thing that we're finding, and this is particularly important, I think, where we were talking at the beginning about this idea that people are trying to constrain us and reduce our scope, we're finding that using these techniques has allowed us to start to expand our scope further forward in the process and further back in the process. So we're using building information modeling to effectively inform client decisions right at inception. So this is really before we get involved in the architecture at all. This is about developing tools to help clients evaluate the capacity of a site. So all we're doing is we're capturing the site through photogrammetry. We can buy this from a bureau for a very nominal amount of money. It's accurate to 40 centimetres, which is as accurate as Ordnance Survey. And bearing in mind that all the client's trying to do at this point is work out whether to buy the site or to develop it or what to put on it. And then what we're doing is using very simple block masses that represent different types of either flat type or room type, that sort of thing. And the information that's attached to those blocks is populating the development plan in real time. So what we can do is if we take a floor off, we can see very quickly whether that makes the project viable or not viable. So it's allowing us to very rapidly look at options at the early stages to help develop an approach to a site, which is something that we were beginning to find that we were being asked to do less and less of. That was being picked up more by project managers and quantity surveyors, that sort of thing. We're beginning to try and take that piece of territory back. The other thing that we're finding is obviously we tend to stay with the project right the way through the construction because of the reliability of the information that we're producing through BIM, which is meaning that at the end of the project we have a complete as-built model of the building. And the realization that our clients are beginning to understand is that has a very real commercial value for them. So they can use that to manage the asset going forwards. And if we structured the information correctly going through the project, all of the components it's effectively a three-dimensional O&M manual. So we are able to capture the actual built asset in a very usable way. So how we've dealt with this within the office is effectively we took a moment and we tried to reimagine the office with building information modelling at the heart of it. And we thought about how we'd like to actually structure the office both physically and virtually. So we've tried to create, we're very conscious of the fact that this is this is all in the computer, it's all virtual. So we wanted to try and find ways of getting what was in the computer out and onto the wall and into the environment. So we're not working very much with physical models anymore, it's all virtual. So we've tried to create an office that has a buzz and an energy about it, to sort of try and take that collaboration part of building information modelling and apply it at a micro level as well as at a project level. So the office is designed around communication. There's a 30-metre long whiteboard with 3 interactive projectors along it, which we can beam up stuff from the computers. Everyone's sitting around a very long, it's a single desk with gaps in it, but it's effectively to try and make the team communicate with each other across the table as well as from side to side. Peer group learning and sharing is really key, particularly with the people that are in our office and the age group that they are. And there's no doubt that there's been a considerable expenditure or investment in technology and the tools for people to use. But actually the biggest investment has been in training and the team. And what we're finding is we have a fairly young office, and they approach problems in a very different way to how I was taught to approach problems. So we would perhaps have just kept going at a problem until we were able to defeat it. What a lot of the guys in our office are doing is ineffective. They come across a problem, they go round it. So they'll go onto their network, they'll go onto social media, they'll look for a solution elsewhere. And that's actually innovation, we realise. So they'll quite often find something on YouTube or a different way of doing things, different way of making the software work to solve a problem. So the challenge for us is to not to stop that innovation, but to put a wrapper around it to make sure that they stay compliant and within the contract and the environment that they're working in. And again, that comes from this sort of structured approach using building information modelling. So at the basis of this, what we've done is we've taken all of our quality management systems and all of the checklists that we were using within the practice, and we've then disassembled them, put the government suite of level 2 documents at the heart, and then restructured our entire workflow around building information modelling and created a single best practice management manual, which is actually quite a small document, but it's got deep dives in it and hyperlinks to all of the documents below it that is accessible, that all of the team members use. So everyone is inducted using this document. And what that means is that they're contributing to building information modelling, even though they might not necessarily know all of the detail of what it is that they're doing. And then that knowledge will just build as they go through the process. And we found that that's been very well received by the accreditation organisations that are checking us for ISO compliance. And we've recently achieved an Investors in People Gold accreditation, which we don't know any other architects that have got that. So we think that's around the fact that this process allows the team to really understand what it is that they're doing and where they are in the process. The other thing that it's doing is because it's adding a layer of quality control through the templates and the processes. It's allowing younger professionals to take more responsibility earlier in their career, which is very motivating and is clearly a good thing for the business as well as being a good thing for them. The other thing that we think is quite important is to have other people come in and look at what you're doing and give you a sort of unfiltered report on where you're at. So this is actually an independent BIM maturity audit that we undertook quite a few years ago now, that gave us effectively a roadmap for how what we were doing well and what we were doing less well, and that allowed us to sort of work out where we ought to put our efforts in training and investment going forwards. And actually, we're being audited again this week while I'm here, so I'm quite glad I'm here. So I thought it might be useful to just look at a few case studies. I'm not going to talk about the buildings as much as the techniques that we've used to sort of design or deliver them. So the first project is a historic project on the outskirts of Cambridge. It's actually a group of 8 historic barns that are listed, of historic interest, and there's 4 new buildings in there as well. The other is the media centre at Lord's Cricket Ground, which I was actually the project architect of first time round, but we've just completed a complete refurbishment of it and an extension of it. And the school project that I mentioned earlier on. So Anstey Hall Barns, so the project is for private homes for sale. They're very nice, they're quite expensive. The site had been around for quite a long time, but was proving very difficult to unlock because of the historic nature of the structure and the fact that they're oak-framed buildings and they were quite precious and of special interest. So the technique, I'll go straight into the techniques once we've gone through this. So you can see that they're beautiful. They're really lovely. This is actually just one home now. But you can see they were in a very dilapidated state. So our approach to this project was really the first thing we needed to do was capture the reality of what was there. So there was already a traditional topographic survey of the building, but we could see just by walking around that wasn't, it had a section taken at 1 metre above floor level, that sort of thing. We could see that the walls were bowed and everything was racking, that sort of thing. So the first process was to laser scan all of the existing buildings. So we had a company come in and capture each of the 8 buildings. We then registered those buildings to ensure that they were those laser scans to ensure that they were in the right place in global coordinates. So they had the right X, Y, and Z coordinates in global space, because that's obviously we're modelling in. We have to model to a datum. We then modelled the existing buildings completely within our software, before then modelling what it is that we were going to do. So we can effectively track the before, during, and after of the project. So you can see the level of detail that we're going to in the model. So this is the completed design. One of the other techniques that we used on this project was that the client wanted to effectively buy all of the materials from the project from our model. So what we did was we agreed that what we would do, we would model in a way whereby we could extract all of the quantities for all of the different materials within the project, which meant modelling in a completely different way to how we've been modelling up until that point, and naming all of our components in a way that would then populate his job book for procurement. What that allowed him to do was, in the first instance, not employ a quantity surveyor, so there was an immediate saving there. But the more interesting development really was that what he was able to do was take the risk in-house of the procurement, of the cost of the materials, which meant that when he went out to the specialist suppliers who were going to build the different components, if he went to 5 people, he got 5 prices back, because they weren't spending time and they weren't pricing the risk of buying the materials. He was taking that risk on board himself, which is one of the things that we think unlocked the project, because it effectively drove quite a lot of cost out of it. But it was quite scary. There was an existing barn on the site that was demolished after completion, which we walked into, was full of materials that he told us he bought off our model. So you felt quite stressed at that point, but it's worked. So really, I won't go into sort of super detail, but what it effectively meant was that we had to model everything that was going to be built. So we weren't just modeling to create 2D drawings. We were everything that he was going to buy was modeled. It went a little bit over the top, so we were modeling. We were even including geometric elements to cover things like EPDMs and sort of damp-proof courses, that sort of stuff, which we could have captured in less time-consuming ways, but it did work. And the big challenge, really, and anyone who's using these sort of softwares knows that we're usually assembling the building out of composite build-ups of materials, so we're out of assemblies. In order to take the quantities out, we have to either model from the very beginning in each separate material, or we have to, at some point, blow it apart so that you can do that, and you can't go back. So the moment that we decide to blow it apart is quite important. So again, careful planning and having a clear roadmap of how you're going to take the project through is really important. So you blow it apart on the right day, really. The other technique that we used on this project that we're now using on quite a few others was a thing called point layout. So what we were doing, we were through the common data environment, which is cloud-based tool that we're using to communicate between the office and the team on site. We agreed all of the setting out points that they would require to be able to build on site, and we embedded little XYZ coordinates within the model. We were sort of thinking of them as little digital diamonds that all had a unique address. And what they had is a total station on site and a wand, like a staff, that could communicate with that, and it could find that point in space. So it's a two-way process. So in the first instance, we validated that the buildings were in the right place in the model by them taking that wand around, finding a point, sending it back to us. Once we were confident about that, all the setting out for the new elements was done the same way, but backwards from us. So that's eliminated the need for a setting out engineer on site. So you can easily see how this is going to move towards things being automated in terms of setting out on site. There were some quite sceptical builders there on the site who'd follow it around with a tape measure, trying to catch it out, but on the whole, it worked. And this is really a screenshot of that in process. So you can see that we've just got little points that we've agreed in advance that we can set out. So this is it in action. So the other key thing with this project is this cloud-based common data environment, and we think that that's the the key thing in the whole BIM process that's really unlocking it. And it's quite an interesting opportunity for architects as well, because many clients don't have one. It's only going to be a sophisticated client that's going to have gone to the effort of setting up this collaborative environment. So we're finding that larger contractors have got them, so we're quite often working on theirs, but in a pre-construction environment, we're taking that role on, which means that we're effectively becoming the place that all of the other consultants are communicating with. And within that software, what we're doing is setting up the workflow for the project and the validation and quality management systems for the information within it. So everything that's happening on the project, the work in progress, the published work, the archive work, is moving through that common data environment in a controlled, transparent way. So we also invite our clients in there so they can see the model whenever they want. They can see that progress is happening. So we're no longer relying on people coming to fortnightly design team meetings, and just reporting on where they're at. We're actually able to work in a much closer to real-time way. And then the great thing is getting that information into the field. So I'm sure we're all used to going to site and discovering that the drawings that got nailed to the wall are 6 months out of date. Here they're actually working with iPads on the site, and they've got the information they've got is bang up to date. In fact, on this project, the contract deliverable was the 3D model, not the 2D drawings. So we did produce drawings, but actually the thing that they would always go back to in the field would be the model. And the site team were trained to actually take dimensions off the model if they needed to. So you can see a situation coming whereby we're not spending lots and lots of time dimensioning our drawings after we've developed them. I'll just flick forwards. So, I think I need to back up. Sorry, oh, no, it's gone. Yeah, so this is again just a screenshot from our or a series of screenshots from that common data environment. And this is this is the part of that space that we're allowing our clients into and the stakeholders into. And what they're able to do is they're able to go in and navigate around the project very easily. You don't need to be trained to be able to do that. And they can comment on the drawings and the models themselves, and that comes back to us. So the whole commenting procedure is done done over the internet. And again, because everything on the project is going through the common data environment, all of the field actions are happening in the common data environment. We're able to see who's keeping up with our RFIs, who's got outstanding issues, that sort of thing. So again, it's a much more transparent and user-friendly way of working. With the listed oak frame, this was the piece of these were the pieces of the barns that were particularly precious to the historic building officer. So what we did was because we've modelled it, every piece of the timber has got a unique identifier, it's got a unique address, and the carpenters on site were able to photograph that piece of timber before they did the work and after they did the work, and they recorded what they did to that piece of timber into that cloud-based common data environment. And that was shared with the historic building officer and also used to sort of quantify the work that was actually done. So we were able to sort of justify what we've got. And we've also got a record going forwards should any work be done on the project again in the future. So it's that ability to give everything a unique address is hugely valuable. So I'll speed up a little bit. So there's an image of the site during construction. We got drone photographs every month, which was really quite nice, but was just really quite nice. There was no real reason for doing it. This is the large barn under construction. This is one of the smaller barns. I quite like this photograph because effectively it's hovering at this point. It's a metre off the ground. We've underpinned it, held it up. Nothing fell off. And one of the other barns, again, there was very little of it left after we took away the modern additions, but it's actually a 17th century barn, so again was protected. So the walls were retained and restored, but the whole of the interior was replaced, and the whole of the structure was replaced with a new CNC cut cross-laminated timber structure in the inside, which went up in 10 days. So it solved lots and lots of site problems. There was no scaffolding, no temporary works. We were able to just drop the interior into the building and then complete it. So the media centre, this project, particularly close to my heart because it's a project I spent an awful lot of time on when I was a younger architect. It was completed for the 1999 World Cup, but in the intervening time, it really got to a point where it was almost not functioning properly. So the demands of the broadcasters had moved on so much since that time that it was actually beginning to be almost threatened. So would they need another one? Would they need to build something next to it? That sort of thing. So what was happening was that the demands of the broadcasters are much higher. They want bigger TV studios. They need better acoustics. They needed a much bigger camera gantry, that sort of thing. And a good example of that is that it actually had a dark room in there for developing photographs, which is now a bar. So, so things have moved on quite a lot. So the client was asking us whether we could find a way of making it function into the future. So the project has involved taking out the interior and putting a new interior in there. And we've actually managed to increase the floor area inside the building by 15%. And I'll explain how we've done that in a second. And we've also attached a new camera gantry to the underside of the building, which now is much bigger and covers the whole of the pitch. So the building itself, so you understand the context, really the main thing that is of interest was that it was prefabricated off-site in 26 very large aluminium pieces that were welded together 15 metres off the ground at the ground. It was the world's first civilian semi-monocoque structure. And all aluminium, built in two shipyards, one in the UK and one in Holland. And these are some photographs of some of the elements being delivered and the top half of the building being built in. This is actually the shed in Rotterdam. And those 26 components, 26 pieces were delivered to site in these very large chunks, completely finished. So they were painted and furred, ready to go, loosely bolted together on a jig, 15 metres off the ground, completely welded in a weld sequence that didn't lock in any pressures, and then depropped. So the building itself is working extraordinarily hard. It's got no expansion joints in it at all, and there's no expansion between the shell and the concrete towers that it sits on. The building itself is cantilevered forwards off the towers, so there's a turning moment on the towers, and the towers have got a tension and compression piles in it. So the actual structure is working extraordinarily hard already, which is where the building information modelling came in, and we had this issue of addressing the camera gantry. So the camera gantry that was there previously actually sits on the stands below, but only covers the very central pitches of the ground. And it's also set back behind the building. So when there's a high ball, they can only track it to a certain point, and then effectively the camera hits the underside of the building. So the design was to create a much bigger camera gantry, much deeper, but that covered all of the pitches, but was also much further forward so it could track the high balls. But it could no longer sit on the stands because that's where the people are sitting. So it had to be suspended from the underside of the building, which is already working very hard. And this is a 30-ton structure that is also cantilevered forwards off a building that is cantilevering forwards. So there was a very real structural conundrum there. The building, when it was developed in the first instance, was actually all done in 2D. So we didn't have 3D. It was the very early days of 3D CAM. We didn't have it. In fact, we started the project in pencil and ink. So that kind of dates it a little bit. So really, for us to start, what we had to do was, the starting point was to model what was already there. So this is some early concept drawings from Janka Pliski, who was the architect originally. And there was an idea for there to be a suspended camera gantry in the original competition entry. So what we were able to do was effectively take that concept and argue that this was actually completing part of Jan's original vision. It might not be exactly how he would have done it, but the demands of the broadcasters are much higher now than they would have been at the time. So these are actually, probably aren't coming through very well, but these are original ink drawings from the project first time round. This is how it was built. These are the planning drawings. And these are our model drawings of it now with the larger camera gantry on there. I'm not sure, is that coming out? So this is the approved design that went through planning with the camera gantry. So you could see our challenge with this big piece of steel, and this is it going in on its hangers. So the other challenge we have is the interior, and the whole concept of the building was to develop a program for the interior of the building and then shrink wrap the whole shell around that. So the idea of trying to find more space inside it is fundamentally quite challenging, in that the whole idea was to make it as small as possible in the first place. So this is an image of the shell with nothing in it from the original build, so you can understand where we're coming from. So the starting point was to model the building as designed from the 2D information that we were able to find, and we were able to find very little, which is also quite interesting, because I remember packaging it all up and sending copies to all the appropriate people, and it had all gone. Again, this idea that we can keep a digital record of what we do is really valuable. So what we did is we 3D modeled from the 2D fabrication drawings the shell. We then laser scanned it on site, because there was quite a lot of craft in the construction of the building in the first place, and it wasn't quite how it was drawn. So we were able to analyse that and capture that. And then what we did was, so we now knew where the inside of the shell should be. What we then did was laser scan the inside of the building in order to find where all the voids were inside the building. So we now know we know from the fabrication drawings where we think the shell should be. We've now captured the inside of the building. And then we went through a very detailed coordination exercise to take all of the M&E and push it into a much smaller zone than it was in before. So all of the ductwork's curving in 3 dimensions and is very, very carefully coordinated. And through going through that process, we were able to push the inner shell of the building, the inner architectural shell, much closer to the structural shell, and that allowed us to find 15% extra floor space. So apart from the fact that we're in a way going back to sort out some of the cock-ups we might have made in the first place, which is always a luxury, really, the way we were working first time round, we didn't have the ability to be as precise as we've got now. And we were able to push this really, really carefully. So that's the architectural model. Now, is this going to work? No. So I'll move on. So here you can see the orange line is the old line of the lining on the centre line of the building, and the pink line is where it is now. So you can see that we were able to sort of push things quite a bit further out. So we don't think that level of coordination would have been possible 15 years ago, but it's really unlocked by the model. So this isn't really, this is three-dimensional coordination using the model rather than information management, but it's a really, really useful part of the process. And these are actually CGIs coming straight from the model. It's the building's complete now and does look just like the CGIs, which is always good. So quickly, if I just go through the school project, this is much more of what we do day to day in our office. So this is an extension to a school in East London, quite a big extension. It's a £20 million worth of construction. And the story behind this project was that we had an 18-month period from a blank sheet of paper to delivering a completed school. And if the team were unable to do that, they were going to basically buy a prefabricated pod system, so an off-the-site standard system. So the approach was really to say we need to think of everything that we can do in order to make this program as fast as we possibly can. So we did achieve the 18-month program. In fact, we targeted 17 months in order to try and hit the 18 months and hit the 18 months. We got to planning in 7 weeks from inception, including all of the stakeholder engagement. And it's been well received by the stakeholders. Now, we think all of that is a consequence of the process. So from very inception, we're modeling in our tools, so it's very clear that stakeholders can see what they're going to get. It's managing expectations. We're able to walk them around the building in the software. They're making decisions themselves, so they can influence the building. And that really allowed us to get through those hurdles to get it to planning in 7 weeks. We were then able to procure all of the major packages as soon as it got planning, and it reached what we call financial close, so when the project was agreed. So other processes that went through this, all of the consultants were federating their models together during the design phase, but it's really the structural element that is really important. I would like to go through that. The early stage BREEAM and thermal performance was all done directly from the model as well, so we were able to populate our BREEAM assessments from the information within the model, so we set it up so it could do that. But it's the structure that's particularly interesting. So it's a cross-laminated timber structure. It's come from Austria. It's imported. We don't have the capability of doing this in the UK at the moment. We knew that we were going to use this from inception because it would take the structure off the critical path of the building, because it's going to be CNC cut off-site while we're putting the foundations in. It's a very light structure, so the foundations are just stripped footings. There's no piles or complicated foundations. And the elements come and are positioned very quickly indeed, without the need of scaffolding as well. So it reduces the prelims and the cost of scaffolding. The elements actually come with the edge protection fitted, so they're very safe to work with as well. But the approach was to effectively, we were given a set of rules by the engineer, Ramble, to work with, to make sure that we was getting the panel sizes right while we were designing the classrooms and designing the buildings. We did that within our software, in our model. We then shared that model with Ramble, who developed their CLT model, their structural model. It went backwards and forwards to do the coordination and clash avoidance. That model, their structural model, was then handed over to the fabricator, who then further developed that model. And that coordination process continued to go on on a fortnightly basis, to the point where effectively we were able to coordinate right till the minute that they pressed the button on the CNC machine, and that the model information was then used to drive the CNC machine. So what was in our model is what actually got cut and then loaded up and brought to site. So obviously, because of this process, every component's got a unique address. They're all bar-coded. You know where they are. That we're able to manage them on site in a very knowing way. We even were able to know what was on which lorry when it was going to arrive, and it was stacked in the right way to avoid double handling. Though here's a photograph of some double handling. This is it under construction, and an image of the building when it was completed. So what we were able to do, which we think is particularly gratifying, is we were able to give quite a challenged school a bespoke solution in the time and the price that would be more typical of a standardized solution. So they got something that they're proud of. And it's that mass customization approach that I think is really quite a useful thing to adopt. So if I've got a couple of minutes, I just want to cover, So I think it would be fair to say that this process has cost us a certain amount of money. So wanted just really to look at the ROI, and because we're a smaller organization, we can actually quite easily map the cost of what this has cost us against our fee income. So there's obviously an investment in technology, tools and training. And when we look at that investment, and we've spent the same amount of money every year on year for 10 years. So when we started it was a very large chunk of our turnover. It's now fairly nominal, but it's been really useful to spread it out over that period of time. What we see is actually 50% of that cost, 50% of that investment is in training. And why wouldn't you train your staff? It's about sort of career development and retention of good people. The software's got a very real price, a real cost, but it's there. The hardware is practically not a concern. So the hardware is becoming more and more affordable, and we'd have to buy computers anyway. We're just having to buy slightly better ones. But if we look at this graph, what we've got is what we're showing is our technical staff costs. The pink line is the extra over that we believe we're spending on these techniques. And then the grey bit at the top is basically the makeup of the rest of our overhead and our profit. So the key graph is this one. So the red line is our fee income. The blue line at the bottom is effectively our technical staff costs, and the extra over is just that parallel line above it there. And if we look at the three phases that we were talking about earlier on, about going through that lonely BIM, collaborative BIM, contractual BIM, what we saw in the early stages is where we saw that we were getting some benefits of using these techniques on our own. So that was fine. But once we went into that situation where we were working with other consultants and a little bit with suppliers and contractors, we saw a real increase in our efficiency. Some of that might be a consequence of a small practice growing, but we would say that that was a consequence of taking on these quality-controlled approaches to production of information. It then plateaued. So for a while, that stopped, and we really did think that that was where it would stop. But counterintuitively, now that we're in this contractual BIM environment, where we're now involved in an awful lot more bureaucracy around this process, what we've seen is another spike in our efficiency. And analysing that, what we think that is a consequence of is now having a very clear roadmap from the beginning of a project to the end of a project of what we're going to do, when we're going to do it, who's going to do it, who we're going to collaborate with, at what points. So effectively, by sitting down at the beginning and working all of that out, even though that takes time, it's producing real financial benefits or real efficiency benefits for us. And we think really that this has made it possible for us to effectively, in the first instance, in the early days, survive in a really difficult financial environment, but now really start to thrive as things are moving on. And really, that's the diagram I wanted to complete on. So thank you very much.